Hello everyone. Welcome back to our Apache Hadoop and MapReduce interview question and answer course. Today we are going to discuss a very practical performance tuning question that is often asked in Hadoop interview. The question is, I am loading a 20 GB file into HDFS using HDFS space DFS hyphen put command. It takes around 4 minutes. I tried different block size like 512 MB, 256 MB, 128 MB and 64 MB. But the time remains the same. What could be the bottleneck and how we can improve performance? The question tests your understanding of Hadoop architecture, a write pipeline, disk IO bottleneck, network throughput, parallel ingestion strategies. Let's break it down. The basic throughput calculation 20 GB is 240 seconds, that is 4 minutes, approximately 85 MB per second. 4 minutes equal to 240 seconds. 20 GB is approximate 20 into 1024 MB equal to 20480 MB. Then 2480 MB divided by 240, that is approximate 85 MB per second. Now think carefully. 85 MB per second is actually a very reasonable throughput for single disk read Hadoop protocol overhead, that is HDFS protocol overhead, network transfer, replication factor usually 3. So the key interview point will be the system is not necessarily slow. It may already be operating near hardware limits. Step 2, why block size change does not help. The candidate tried 512 MB block, 256 MB block, 128 MB block, 64 MB block, but the performance remained 4 minutes. Why? Because block size affects number of blocks, metadata in name node, parallel processing during processing. It does not change total amount of data being written, disk read speed, network bandwidth, write pipeline throughput. You are still pushing to 20 GB as a single continuous stream. So changing block size will not magically increase throughput. This is a strong interview explanation. What is the real bottleneck? The real bottleneck is disk IO from a single source. When you use HDFS, DFS hyphen put large file dot data, the file is read from a disk sent as a single stream written via HDFS pipeline. Even though our Hadoop cluster has many nodes, many disks, network bandwidth, you are only using one disk, one input stream. That is the core limitation. HDFS write pipeline. In Hadoop 3, when writing a block, that is client to data node 1, data node 2, data node 3, replication happens in pipeline, but the input is still a single stream. So ingesting parallelism equal to 1. Cluster parallelism is not utilized. How to improve performance? Here the strong interview answer will be, if you cannot change ingestion architecture, you cannot magically improve performance. However, you can improve by increasing parallelism. That is option 1, split the file. Split 20 GB file, that is 20 files of 1 GB each. Then upload in parallel. Example, split space hyphen b 1024 MB large file dot dat to part underscore. Then use HDFS space DFS hyphen put part star to target path, or better run multiple put commands in parallel. Now multiple disk reads simultaneously, multiple network streams, better cluster utilization. Option 2, parallel upload. Use GNU parallel or background process. We'll write ls hyphen space parts underscore star space pipe xarg space hyphen n 1 hyphen p 8 hyphen I curly brackets, then Hadoop space DFS hyphen put, then curly brackets, then to slash target slash path. Now you are using 8 parallel uploads. Performance can increase significantly. Better production solution will be use Apache Flume, use Apache Kafka plus Spark streaming, use disk CP to distribute copy, write directly from application to HDFS. Best practices avoid large single monolithic file. Distributed systems loves distributed input. If interview asks what is the bottleneck and how to improve put performance, your answer will be the bottleneck is the single stream disk IO from the source machine. Changing block size does not help because the total data volumes remains the same. To improve performance, we must increase ingestion parallelism by splitting the file into smaller chunks and upload them in parallel, or redesign the ingestion architecture to support distributed writes. This is a strong senior level answer.